Hello guys, welcome to the lecture 6 of machine learning series. In this video, we'll be discussing about instance based learning and model based learning. Okay, it is a final video on different types of learning. Okay, it is short and simple. Please watch till the end. Okay, first let's discuss about instance based learning. Okay, these are the three important points regarding the instance based learning. Okay, first is store training instance in memory. Okay, it is done by similarity score. Okay, no parameters. Okay, these are basically 3 points of instance based learning. Now we'll be understanding these 3 points in detail with an example. Okay, now let us say we have a classification data set where we have number of rooms, number of floors, and price. Okay, this is basically how our data set looks. Okay, in price column we have either low or high. Okay, it's a binary classification data set. Okay, now let us say we have 10 rooms and 3 floors. Price definitely will be higher. Okay, if we consider 2 rooms 1 floor, price will be definitely lower. Okay, sorry, this is basically our binary classification data set. Now what we do in instance based learning is we basically store this entire data set. Okay, our first point specifies store training instance in memory. Okay, here we store this entire data set. Okay, where we store this entire data set in our memory. Okay, if we have 1 lakh points or 2 lakh points, we store that entire data set in our memory. Okay, after storing this entire data set in the memory, we'll basically plot this data. Okay, after storing the entire data set in the memory, we'll be plotting the data. Okay, let's say this represents number of floors and this represents number of rooms. Okay, as it is a binary classification, we'll be having two classes over here. Okay, yeah, this is our first class representing low price. This is our second class representing higher price. Okay, it is a binary classification problem, so we have two classes over here. Okay, first we have taken our data set, we have loaded into our memory, then we have plotted the data set. Okay, next what we'll be doing, okay, is done by similarity score. Okay, the second point specifies now in this entire plotting. Okay, after plotting this entire data, will be not training. Okay, there is no training step involved in instance based learning. Okay, after storing this entire data, we'll be taking directly the data point for prediction. Okay, we'll be directly testing the data point. Okay, we'll be directly making the predictions on a data point. Now let us say we have a data point where we have total number of rooms as 4 and total number of rooms as 4 and floors as 2, and we need to predict whether the price is high or low. Okay, we need to predict whether price is high or low. Now what we do here is we'll be directly taking this. Okay, we'll be directly taking the coordinates of this point and we'll be comparing with each of these points. Okay, we have taken first our training data set. Okay, entire data set, and then we have plotted, and directly we are taking a point for prediction. Okay, directly we are taking a point for prediction without any explicit training. Okay, now this is our data point. Now we'll be comparing this data point with all these data points. Okay, with all these data points, if we have 1 lakh data points, we'll be comparing this data point with all the 1 lakh data points. Okay, how we'll be comparing? By similarity score. Okay, the metric we use is similarity score. Okay, the similarity score can be Euclidean distance or Manhattan distance. Okay, it may be Euclidean distance or Manhattan distance. Okay, we'll be taking this data point, we'll be calculating the similarity score with each of these data points. Okay, if you have 1 lakh data points, we'll be comparing with all the 1 lakh data points. Okay, after comparing with all the data points, we'll be taking top 7 or top k data samples. Okay, in our case we have taken top 7. Okay, in our case we have taken top 7. You may take top 14 or top 20. Okay, top any odd number. Okay, basically take any odd number. Okay, I have taken top 7. Okay, now what we will be doing is we will be taking top 7 similarity scores. Right, we'll be taking top 7 similarity scores. Now let us say we have compared this data point with all these data points, and we'll be writing each of this similarity scores in ascending order. Okay, sorry, in descending order. We'll be writing each of the similarity scores in descending order. After writing this similarity scores in descending order, we'll be taking top 7. Okay, we'll be considering only top 7 similarity scores. Okay, now after considering this top 7 similarity scores, we'll be then counting the number of labels. Okay, then we'll be counting the number of labels. First, we'll be seeing how many high are among the 7. Okay, how many data points are labeled as high among these 7. Let us say we have 3 high and 4 low. Okay, now we'll be going with the majority score. Okay, we'll be going with majority score. As 4 are labeled as low in this top 7, we'll be considering this prediction as low. Okay, we'll be taking this prediction as low. Okay, this is how instance based learning works. Okay, we'll be taking similarity score. And the third point is there are no parameters. Okay, there are no parameters in this entire process. Okay, when you observe this entire flow, okay, where we load our data set into the memory, and where we plot, and where we calculate the similarity score, and where we output our prediction, there are no parameters involved. Okay, there are no weight values or bias values involved in this entire process. Okay, there are no weight values and no bias values. This is an this is just a training without any parameters. Okay, this is a training without any parameters. It's a non-parametrical training. Okay, it's a non-parametrical training. Instance based learning is a non-parametrical training. Okay, this is how instance based learning works. Okay, first we take in a data set, we load it into our memory, then we'll be plotting our data set. After plotting our data set, we'll be directly taking, okay, we'll be directly taking a test sample for the prediction. Okay, we'll be not doing any training. Okay, we'll be not performing any training, but just we'll be taking a data sample for testing. Okay, after the similarity score everything is done, we'll be taking top label. Okay, the top label among the top 7, okay, top k similarity scores. Okay, after that we'll be assigning the label. This is how instance based learning works. Okay, now let us see some uh, advantages and disadvantages of this instance based learning. Okay, first, when it comes to advantage, it is simple. Okay, it is basically simple. There is no like training adjusting the parameters. Sorry, there is no adjustment of the parameters. Nothing is there over here. Okay, we are not even taking a complex model over here. So it is simple. Okay, it is very simple without any parameters. Just we are just predicting the label of the data point without any training. Okay, so it is simple. There is no training time. Okay, as there is no training, we don't have any training time over here. We'll be doing directly the prediction. Okay, works for small data set. Okay, it is well suited for small data set. Okay, for small data sets, it gives better accuracy as well as less time. Okay, the time will be less and accuracy will be more. Okay, now when it comes to cons, okay, when it comes to disadvantages, it is slow for prediction. Okay, why it is slow for prediction? Now let us say we have 1 lakh data points, means we'll be having 1 lakh data points over here. Okay, in this plot we'll be having 1 lakh data points. Now for testing a single data point, okay, now for calculating the label for this single data point, I need to compare this data point with all the 1 lakh data points. Okay, at the time of prediction, I need to compare this data point with all the other 1 lakh data points. So this takes some amount of time, right? This takes some amount of time. Okay, so that is why the prediction is slow. Okay, that prediction is very much slow in instance based learning. Okay, now second is intensive memory usage. Okay, now let us say we want to deploy this model in the production. Okay, now for deploying this model in the production, we are not directly deploying the model, but we are deploying the entire data points. Okay, if we have 1 lakh data points, we are deploying the entire 1 lakh data points on the server. Okay, we are not just deploying the model, but our entire 1 lakh data points into the model. So it is very much costly. Okay, it is very much costly to deploy 1 lakh data points onto the server. So it is intensive memory usage. Okay, it uses memory a lot. It is not suitable for production. Okay, it is not suitable for production. Instance based learning is not suited for production. Okay, this is basically the entire explanation of instance based learning. So to solve all these problems, we have model based learning, which we'll be discussing further. Now let us discuss the type of learning that has solved all the problems of instance based learning, that is model based learning. Okay, these are the important points of model based learning. First, mathematical function. Second, adjust parameters to minimize the loss. Third, output from learned parameters. Okay, these are the three important points. Now let's decode these important points with an example. Now we'll be taking the same data set, that is number of rooms, floors, and price, and 10 rooms, 3 floors, price high, and 2 1 look. Okay, let's say this is our data set. Okay, now what we will be doing is, after considering the data set, we choose an algorithm. Okay, after considering this data set, based on the data set, we choose an algorithm. Now you see that we have we have two classes over here. Okay, that is high and low. Okay, so it is a binary classification problem. Now to solve binary classification problem, we have logistic regression, SVM, like algorithms. Okay, we have logistic regression, SVM, and some further algorithms. Okay, now after choosing the dataset, we choose a right algorithm. After choosing the right algorithm, we train this algorithm on this dataset. Okay, after choosing the right algorithm, we'll be training this algorithm. Okay, we'll be training this algorithm on this dataset. Okay, now let us say we choose logistic regression, and let's say for this training data, I have my logistic regression decision boundary this way. Okay, this is my logistic regression decision boundary. Okay, what logistic regression does, it is basically used for classification purpose. Okay, for binary classification we use logistic regression. Okay, for binary classification we use logistic regression. Okay, now as I've used logistic regression algorithm, it has classified higher and lower. Okay, higher, this is higher price, and this is lower price of the house. Okay, now now let's compare this points with this example. Now first we have mathematical function. Okay, here what is mathematical function? This decision boundary is our mathematical function. Okay, here we have mathematical function which maps inputs to the output. Okay, how this how this outputs are occurred based on this inputs. Okay, how this outputs have occurred based on this inputs. Okay, will be having some mathematical connection. That mathematical connection is this decision boundary. Okay, that mathematical connection is this decision boundary. Okay, second, adjust parameters to minimize the loss. Okay, here in logistic regression we have weights and bias parameters. Okay, I'll be explaining you in depth of this logistic regression in the further parts of our playlist, but just have an understanding that we'll be having some weights and bias parameters in this logistic regression. Now what this weights and bias parameters does is, first we'll be initializing some random values to this weights and bias parameters. Now the further parts of the training, based on the loss, we'll be adjusting this weights and bias parameters. Okay, first we'll be initializing some random parameters. Okay, some random weights and bias values. Now as the training goes on, okay, as the training goes on, at the end of the training we'll be having some fixed weights and bias parameters based on this loss. Okay, based on the loss, these parameters are getting adjusted. Okay, so this entire training process involves the adjustment of the weights and bias parameters. Okay, second is output from learned parameters. Okay, we'll be having the output based on this learned parameters. Okay, this entire learned parameters will be affecting our output. Okay, will be giving our predicted output. Now let us say we have an test data point. Okay, where our test data point has 10 rooms and 5 floors, and we need to predict the price of the house. Now here what happens is, we'll be considering this features. Okay, now after considering these features, we'll be plotting it over here. Okay, you just remember it as decision boundary. So after taking this decision boundary, we'll be taking our test data. After considering the test data, we'll be basically plotting this over here. Okay, we'll be not calculating any similarity score, but we'll be just plotting. Okay, just will be plotting it over here. After plotting it over here, let's say we have the point as here. Okay, we have point over here. Okay, now you see that it is the right side of the decision boundary. Okay, it is on the right side of the decision boundary, so it is, sorry, so it is labeled as high. Okay, as it is on the right side of the decision boundary, it is labeled as high. Okay, you see that after some amount of training, we are predicting the output very much faster. Okay, we are not just calculating any similarity scores and we are not choosing some top 7 or top 10 similarity scores, but just we are mapping it to a graph. Okay, we are taking our data point and we are just plotting it on a graph. After plotting it on the graph, we are able to get this decision boundary. Sorry, we are able to get this label. Okay, so it is very much easier at the time of prediction, okay, or at the time of testing. Okay, so these are the three important points regarding model based learning. Okay, first we'll be having the data set, then we'll be training our model on this data set. After the training, we'll be having some decision boundary or some regression line. Okay, after taking this decision boundary, we'll be taking the test data. Okay, after entire training process completes, we'll be taking the test data and we'll be directly testing it over here. Okay, we'll be directly plotting and deciding the decision bound. Sorry, we'll be deciding the label. Okay, this is how model based learning works. Okay, now the pros comes. Okay, now when it comes to pros, first, store parameters only. Okay, we just store the parameters, not entire data. Okay, we'll be not storing the entire data but just parameters. Okay, now let's say we have deployed the same model on our environment. Okay, sorry, on our server. Okay, now by removing all this, okay, after getting the decision boundary, we'll be removing all these data points. Okay, after getting the decision boundary, we'll be removing this all data points and we'll be just considering the decision boundary. Okay, we'll be not taking the entire data but just considering the decision boundary. What decision boundary means? The model parameters. Okay, the model learned parameters. Okay, what decision boundary means? Model learned parameters, that is weights and bias values. Okay, means we'll be taking only parameters for storage. Okay, we'll be just storing the parameters, not the entire data. Means we'll be storing entire model. Okay, means we'll be storing the entire model but not data. Okay, but not data. Okay, now second, faster predictions. Okay, you see that we are directly plotting it over here. Okay, let's say 10 comma 5 is over here, we'll be deciding the label. Okay, just we need a decision boundary. Okay, we just need a decision boundary. After deciding the decision boundary, the prediction time is being very much faster. Okay, the training time is definitely being slower but predictions are being so faster. Okay, now better predictions. Okay, as we are training and model, okay, we are training our model on the entire data set, we will be having better predictions than the instance based learning. Okay, in model based learning, we'll be having better predictions than the instance based learning. Okay, remember that point. Fourth is less memory, as we are just storing our parameters. Okay, now let's say for this logistic regression, let's say we have around 10 to 20 parameters. Okay, let's say we have started with a small, okay, smaller model, so we'll be having just 10 to 20 parameters. Now we'll be just storing the 10 to 20 parameters in our memory but not this entire data, so the memory consumption will be very much less. Okay, we'll be just showing the parameters or hyperparameters. Okay, now when it comes to some disadvantages, we need to choose the right algorithm. Okay, for a corresponding data set, right algorithm is very much important. Okay, for a data set, choosing the right algorithm affects the model predictions. Okay, affects the model prediction. So choosing the right algorithm is a little difficult task, but each of these cons have a solution. Okay, even for the right algorithm we have solution, and even for underfitting and overfitting problem we have a solution. Here we have the problems with solution. Okay, yeah, right algorithm and underfitting and overfitting. Okay, we'll be understanding, sorry, we'll be discussing this underfitting and overfitting in the further parts of our playlist. Okay, this is basically our model based learning. Okay, hope you guys enjoyed this video. If you like the video, please like, share and subscribe. Thank you.